Time, a brief history. My virtual field trip project. A guide. These are all the topics we are going to be covering. Measuring time. Before any real clock, we use a clock that you could say ticked once. We use the rotation of the sun and counted off the sunrise and sunset to count off days. After that, we use the sundials to further divide days into hours. We then use a pendulum to divide hours into minutes and seconds. After that, we then use the vibration of a quartz crystal to divide seconds into milliseconds. But the most precise clocks in the world is an atomic clock. It works by counting the ticks of a cesium atom, a rare metal. They charge it with energy and then count the number of light ticks it emits per second. A cesium atom ticks 9.1 billion times a second. The consistency of it is what makes it used to be a clock. And from the ticks of the atom, we get the most accurate clock you'll ever find. The passage. Time, like a river, seems to flow endlessly in one direction from moment to moment. So how do we know it exists? Well, we use hourglasses with flowing sands to highlight when a certain amount of time has actually passed. And as time passes, fruit and other organic items begin to rot. Another piece of evidence that time relatively exists. As we are sure that our past and future don't exist in the present, the past may not actually be gone, and our future may actually exist already. Let's see. Diversion of time and space. If two cars were going in the same direction, one north and one northwest, the north one will be covering more distance north because the northwest coverage is being divided by the north and west. Time and space work is similar to how north and west work. Depending on how you're moving, you would appear faster or slower if your motion is divided or not. If you're standing still, you are not moving through space, but you are moving through time. Since the man sitting is also not moving, both their clocks are the same. However, if you are moving, you're moving through time and space, so you'd appear slower because your motion is diverted to the man, and he's standing still. The clocks are now different, but only by a minuscule amount. This theory by Albert Einstein was tested with two atomic clocks, one in motion and one still. The one in motion moved a nanosecond slower compared to the one sitting still. It was a very small amount, but the idea was very real. Diversion of time part 2. A now slice is basically a frame of time we're on this earth and everywhere a universe coexists, like me and you. If me and an alien were both standing still, we would both be sharing a now slice because our motion isn't being diverted by time and space, only time. However, if that alien were to move away from Earth, his motion is being diverted and we no longer share the same now slice. However, that alien now shares a now slice with someone centuries in the past because that small difference increasing over a vast amount of space leads to a great change. In the same way, if that alien were to move towards Earth, he'd be sharing a now slice with someone centuries in the future. These small differences are an actual and indirect way of time travel. Manipulation. Because of the slight difference in a gravitational pull, a person living on the bottom floor would be moving slightly slower than someone living on top. With the same concept, if you were to be orbit around a black hole, you would feel normal, but to someone on Earth, you'd be moving very slow. So years might be passing for Earth, when minutes are for you. When you come back, even if a few hours have passed, you only aged that same amount of time. People of Earth would have aged decades because of the difference of pull. But according to the laws, that's the future though. But according to the laws of physics, wormholes could also exist. Wormholes not only connect place to place, but moment to moment. If these are proved to be existing, these can help for time travel to the past. Complexity in the error of time. The error of time is the notion that everything moves towards the future, but that isn't always set in stone. Lots of equations and laws of physics don't have an arrow of time attached to them. These fundamentals can work just as well backwards as forwards. Equations in physics are what we use to describe everything, like the behavior of atoms or the swirls of galaxy. But not one of them restrict time travel or things happening in reverse. So why hasn't it happened? If you were to drop a glass of grape juice, it would fall and then shatter. This would be following the laws of physics and our laws of interpretation. However, the laws of physics states that if you were to it could form back to a regular glass of wine, grape juice, if you'd reverse the velocity of every atom making up the juice in the glass. If you were to take a book, rip up the pages, and then throw it, the reason why the papers don't land directly stacked on top of each other is because there are billions of ways that the papers can fall, and only one way it can land back together. So the chances are right next to impossible but not completely gone. There are more ways for the papers to become disorganized instead of organized, and this is what we actually experience in our daily lives, which is why things don't always happen in reverse. Disorder. As the era of time continues and time evolves, our world becomes more and more organized, like an egg sliding on the ground, or smoke billowing in unpredictable patterns in the sky, or ice cubes lose their orderly form as they heat up, turning into water that has no shape or solid substance, or glass breaking and shattering into disorganized pieces and going into unpredictable directions. So, if the universe and everything in it became more disorderly as time continues, then the further you go back in time, the further organized it becomes. This means that the most orderly thing in the history of time was the Big Bang, since time and space didn't exist before then. The Big Bang is the most ordered thing in the laws of physics. Everything after that has become an increase of disorder. Finally, the Big Bang gives us the reason why why things don't progress when you move backwards in time, which semi-solidifies the concept of the arrow of time, and somewhat solidifies the laws of physics. But nothing is yet set in stone, and time travel can still happen. It's just a matter of how we use that information already given to us.